Dear students, today in this session we shall discuss about electric motors. So the motors are used as power supply in variety of mechatronic applications. Electric motors often feature as prime mover in variety of driven systems. So the electric motor, it is also called as prime mover because it is the main source which supply power to other machines or equipments. They can either be classified on basis of functionality or electromagnetic characteristics. The difference in electric motors in mainly in rotor design and the method of generating the magnetic field. So in electric motors there are three types. One is DC motor, AC motor and stepper motors. We shall see one by one. So DC motor speeds can be smoothly controlled and they are reversible in nature. They also respond very quickly. These motors are based on principle of electromagnetic induction. That is, when a current carrying conductor is placed in magnetic field, it experiences a mechanical force. So this is the statement of electromagnetic induction. In conventional DC motors, several coils of wires are mounted in slots on a cylinder of magnetic material called armature. The armature is mounted on bearing and it is free to rotate. It is connected to direct current through a switch mounted on the shaft and it is called commutator. When an electric current flows through the armature conductor placed in the magnetic field, it experiences a force which causes the armature to rotate. So as the armature rotates, the commutator is reversed the current in each coil as it moves between field poles. As the commutator are split, the current direction through coil reverses each half of the rotation and torque is present all time and coil continues to rotate in same direction. The direction motors are used in large number of mechatronic designs because of the torque speed characteristics achievable with different electrical configurations. So next one is AC motors. So AC motor is an electric motor driven by alternating current. So it consists of mainly two parts, stator and rotor. Figure A is a stator and figure B shows rotor. An outside stationary stator having coil supplied with alternating current to produce a rotating magnetic field. An inside rotor attached to the output shaft producing a second rotating magnetic field. The main parts in an AC induction motor are rotor and stator. The rotor construction looks like squirrel cage, hence it is called squirrel cage induction motor and is made of copper or aluminum bars and it fits into slots in each rings to form complete electrical circuits. A single phase motor has only one stator winding. The winding generates a field which merely pulsates instead of rotating. When the rotor is stationary, the expanding and collapsing these currents generate a rotor field opposite in polarity to that of the stator. The opposition of the field exerts turning force on the upper and lower parts of the rotor, trying to turn 180 degrees from its position. Since these forces are exerted through the center of rotor, the turning force is equal in each direction. Next one is relays. These are the electrically operated switches in which changing current in one electric circuit switches current on or off in the another circuit. So if there will be two circuits, the current flow in one circuit is dependent on the current flow in another circuit. For the relay shown in figure, when there is a current through the solenoid of the relay, a magnetic field is produced which attracts the iron armature, moves the push rod and closes the normally open switch contacts and opens the normally closed switch contacts. Relays are often used in control systems in conjunction with transistors. Next is diodes. Diodes are the devices which conduct electric currents in only one direction, that is during forward bias condition. It will not conduct any electric current during reverse bias condition and it acts like open conductor. So in the figure shows the characteristics of diode in forward bias condition and reverse bias condition. The graph is plotted on voltage versus current on x and y axis. So in the forward bias you can see that the cutoff voltage is 0.7 volts. So when the current pass above the value of 0.7 volts, it easily conducts in forward bias condition, and in the reverse bias condition the diode will not conduct electric current until some considerably high voltage. So after that high voltage is achieved, it will start conducting. Next is thyristors. Thyristor or silicon controlled rectifier can be regarded as a diode which has gate controlling the conditions under which diode can be switched on. Figure shows the thyristor characteristics. With the gate current 0, the thyristor passes negligible current when reverse biased. When forward biased, the current is also negligible until the forward breakdown voltage is exceeded. The voltage across the diode falls to low level of about 1 to 2 volts, and the current is only limited by the external resistance in the circuit. Next is triac. Triac is a combination of two thyristors um, connected in opposite direction or reverse direction. The triac can be termed in either the forward or reverse direction. Triacs are simple and relatively inexpensive methods of controlling AC power. Next is solenoid. So it is used for translating on-off electrical signals to mechanical movements and normally used as linear actuator. So this is also used as switches for controlling mechanical systems. A solenoid is made of coil with movable iron core. The coil will have same voltage or current rating and may be AC or DC. When the coil is energized, the core is pulled inside the coil, and the amount of force by which the coil is pulled mainly depends upon the number of coils and the amount of current flowing in the circuit. So here also it also works on principle of electromagnetic induction. That is here we are not moving the coil which is carrying current, but the coil is stationary and we are moving soft iron core inside the electric wires. So there will be some difference in magnetic fields generated, and it is used as the switch to control electric or mechanical systems. Next is piezoelectric actuators. So it achieves displacement by directly applying deformation of the solid, thus features a higher displacement accuracy, larger generation force and higher response speed than other types of actuators. A piezoelectric ceramic material is used in piezoelectric actuator which generates electric energy when it is subjected to mechanical energy. Any material called piezoelectric material when it is generating some voltages when it is applied with electric force. Also there will be inverse piezoelectric effect also, that is if you apply an electric field to a material, it generates mechanical force. So this is inverse piezoelectric law, and material works on vice versa in both the directions. That is, you can apply force and generate current, or if you apply current you can generate force. In the figure it is shown. So when we are applying force on the piezoelectric material, it will generate electric voltage, and this can be seen in the voltmeter which is connected in the external circuit. These advantages have resulted in piezoelectric actuator being applied in many industrial equipments which require precision position control. The applications are used in scanning tunnel microscopy and atomic force microscopy. So piezoelectric actuators is mainly applied in these two instruments. Next is shape memory alloys. So as the name itself says, the alloys which remembers its original shape. So those materials are known as shape memory alloys. These are used in mechanical and electric systems. So due to any external circumstances, these materials are applied and they get deformed. So after removing of forces, they come back to their original shape. So these materials remember their original shape and return to it when heated, even or cooled, or when the forces are released. Even if apparent residual deformation was introduced below a certain temperature, so they are called shape memory alloy. The original shape can be set easily by a heat treatment. The shape memory alloy crystallographic structure changes between two phases, the low temperature and high temperature phases. Shape memory alloys, they are used as actuators in many electronic and mechanical equipments. They are useful for such things as actuators, which are materials that change shape, stiffness, position, natural frequency, and other mechanical characteristics in response to temperature. The shape memory alloys actuators are made of wire, spring, or ribbon shaped material. It is able to produce extreme forces from the viewpoint of volume to force ratio one way. That is one way shape memory effect. Element can only provide force displacement in one direction. So one way means it can produce only force and displacement only in one direction, single direction. A bias mechanism must be used if the actuator has to be returned to the original shape after the heating phase. So that is how they use shape memory alloys as actuators. Thank you guys.